Welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a rubber bar for its tensile analysis. We are going to use the explicit dynamics module. Also, we will be using the flat specimen which we have used for the tensile test of steel and composite bar. So we will start by double clicking on explicit dynamics module. Then I'll go to engineering data and double click. Engineering data sources. Here I'll go to explicit materials and double click. Here we'll choose rubber as the material. Now there are two of them. You can use any one of the two. I'm using the first one. I'll click on engineering data sources again. So I can see this material rubber. The density is 1000 kg per meter cube and rest of the properties have been given. So we'll go to project and update project. Next I'll go to geometry and right click and insert the geometry which we have already made of the flat specimen. I don't want to make any changes to it, so I'll directly go to model and double click. I'll first go to geometry solid and change the material to rubber that we have selected. Next I'll go to mesh. I'll choose the size as say 4.5 mm and generate. So once the meshing is done, I'll go to explicit dynamics analysis settings. I'll change the timing to 0.001 second. Then I'll go to explicit dynamics and insert fixed support at one end. Apply. Then I'll insert displacement at the other end. I'll give this value as say 60 mm. Then I'll go to solution and insert deformation stress equivalent. I'll insert strain equivalent plastic. I'll go to solution and solve. We go to equivalent stress. I just align the body vertically. So you can animate and check this result. It is showing a deformation over here of 60 mm. You can see the graph of stress versus time. You can see the stress is linearly increasing. Then it is reaching its peak and then slowly it is reducing. The maximum stress over here is 5.824 megapascal. Next we'll go to equivalent plane strain. You can see here there is no strain. The reason is because it is rubber. So whatever deformation is there in one direction will be adjusted in the other direction. So once you can see this, you can change this value of displacement. Say you want it to be 65 mm and solve once again. So you can see here when I give the displacement as 65 mm, we can see that after deformation there is a certain material which is breaking off, which shows that there will be breaking of rubber at one end if you give it a displacement of 65 mm. And also you read this graph, you can see it is reaching a maximum value of stress, then it is reducing, and then you can see a failure over here after a particular point. There is a continuous reduction, which means there will be a failure at this point, which is shown over here. So you can also see the strain, it is 0 over the period of time because the energy which is lost by changing of dimension in one direction will be adjusted in the other direction. It is about the energy, it is about the change in dimension which happens, volumetric strain as you can say. So because of this, you get this kind of result. The value of Poisson's ratio for rubber is maximum in this world, which is 0.5 because of its highest elasticity. So that is why you can see that change in dimension in one direction will lead to equivalent adjustment in the other direction, but there will not be any change in length or width. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.